Okay, so 3 we said 0.743, 4 we said 0.712.
Yep.
5, you get A.
Oh, you know what? You're right. Yeah, I put D, but I see it that I put P hats, not D.
Okay.
Okay.
Number 6, I thought that the point estimator is supposed to be like the
That's your P
x1
value.
plus x2 divided by n1 plus n2, but I don't know how to do the point estimate. Do you?
Isn't the point estimate? Hold on a sec.
Value. Yeah.
You hear this or no?
Barely.
Okay.
0.599. So since, and this is how it's displayed here using the method, 0.526 just shaded both sides and got the area which matches this 0.599. Now since my p-value is greater than my alpha,
I was right here at the point estimate when we started it. So.
Oh, really? Okay.
Say the proportion. Since it's no hypothesis here. So knowledge is, let's go through one more example. So here's an example where some people are thinking
Well, he's not saying anything about the point estimate.
So
of course he's not.
Let's go through one more example. So we state no, and I will not, and we're not protecting.
If I can find anything.
Shaded both sides and got the area which matches this 0.599. Now since my p-value is greater than my alpha, then I will not, and we're not protecting my hypothesis. It means sufficient evidence to say that the proportion that so we state the null hypothesis.
Oh, maybe it was on the first video. It's P.
So
wouldn't that be the middle? So if you have P1, P2, well, I don't know, and then we use the z-score 394 and we use the middle, wouldn't that be a point estimate?
not sure. You mean the middle of the upper and lower?
Yeah.
So 0.308. I don't know. You can try that one. Let me read the paragraph thing again real quick. Actually, excuse me.
Bless you.
Excuse me, thanks. So I remember in the reading these big equations. That the arrow that goes above the P.
Yeah. The P hat.
So to do that minus P, and P they were putting in 0. And 0 is in between the upper and lower bound on this one. So I think it might even be 0 for that.
The point estimate will be 0?
Yeah, so a point estimate is just a point along the line, right? And so with the lower bound is negative 0.123.
Oh, you know what? I think you're right, because, yeah, isn't everything based off of 0 or something like that? I remember.
Yeah.
I remember listening to something about that.
Yeah.
You try that one. They're all pretty close.
Yeah. And then number 7, that's the margin of error. So you take the upper minus the lower, divide by 2, and I got 0.154.
0.154?
Yeah. Number 8, for the lower bound, I got negative 0.123.
Okay, on the margin of error, you said 0.154.
Yeah.
All right, your confidence interval is negative 0.123 and 0.185, right?
Yep.
Okay. Don't you have to divide that by 2?
Yeah, so you do 0.185 minus negative 0.123 and divide it by 2.
Okay. I just want to make sure. All right. .62 divided by 2. Hang on, those are wrong. I got 0.031 on that. Yours is probably totally right.
So you gotta remember that there's still a negative. So 0.185 minus negative 0.123. So it's basically 0.185 plus 0.123. For that answer, you get 0.308. You divide that by 2, and you get 0.154.
Okay. All right, I gotcha.
Number 10 is A.
I got A.
Number 11, B is in dog.
Yep.
12, true.
Yep.
13, D is in dog.
I got dog.
14.141.
Yep.
15.145.
Yes, sir.
16, negative 2.020.
Got that one right.
17 is to the left.
Yep.
18.022.
Yes, sir.
19 is reject.
Yep.
And 20 is C.
Got that one. Sweet.
Perfect. Let's do this.
Sweet. Sounds good to me. Oh, I missed one. Where did I miss one at? Oh, the point estimate. It's not 0.
Oh, let's see, that was number 6, I think, right? Yeah, that's the
Yeah,
one.
number 6.
Yeah, that was hard. I don't even know what it'd be then, because that's the only thing I can think of. Besides what you're saying, what were you saying earlier is,
Well, here's off Google. It says point estimate of a population parameter is a single value of a statistic. For example, a sample mean X is point estimate of the population mean. Similarly, the sample proportion P is a point estimate of the population proportion P interval and estimate.
on your Excel file where it says P-hat1 and P-hat2.
Right.
Your P1, that one is 0.743 and the other one is 0.712, right?
Right.
So
don't you subtract, well, like this, like it's saying it's confidence interval, wouldn't it be the well, it's going to be a number, huh?
Yeah.
Like in between. So if you're a 743, is it going to be an average? Would you average those two out?
Yeah, I don't know. That's what I was wondering because we could add those. I kind of wrote that down for a guess. Wrote those added and divided by 2 and got 0.728. But that's not on the line between the upper and lower.
Right. Well, I guess we're going to have to go dig through it and figure out what that one is.
Yeah, let me see if I can dig.
All right, where did we leave?
Oh, this is really cool. Math.
P hat is a sample proportion. P is the population proportion, and the P naught is the population proportion for null hypothesis. So I think that means something somewhere. So everything to the right is right. Plus minus is margin of error. Mr. Josh.
Mr. Josh.
What's up, buddy?
Doing good, man. Good to see you.
See, he'll know.
Yeah, maybe he will. Hey, Josh, did you do it already? All right. So we took it once and just once, and we're just trying to find number 6. So if you want, I'll run through the questions with you real quick to get up to speed. All right. You ready, I'm going to start going through them. So 1 and 2, of course, are true. 3, 0.743. 4. Number 3 is 0.743. 4 is 0.712. 5 is A. 6, we don't know yet. 7.154. 8, negative 0.123. 9.185.
Wow, you guys are already done, huh? Pretty quick.
Yeah, it was easy.
All right. Thanks. My bad. I lost track of the time.
No worries. Hope you're winning at chess.
Yeah. Okay. So the margin of error.
The point estimate.
Okay.
Number 6. The point estimate. Yeah.
All right. Just 1 second. See if I can.
Let me see if I can watch the video and figure that out.
Someone getting some housework done.
What?
Let's hear this banging in the background.
Oh. Yeah, I don't know.
That's what I thought.